problem we were given asks how many of these molecules are polar. The first molecule we were given is SO3. To start off with, we have to draw the Lewis structure. To do that, we have to find the amount of valence electrons, which totals to be 24, and we place them around the O's, forming octets. We put the S in the middle because it's the most electronegative, and yeah. So after that, to determine the bond dipoles, we find which atom is more electronegative. Since O is further towards the top right corner of the periodic table, it's more electronegative. So the bond dipoles point outwards towards them. The molecular geometry of SO3 is trigonal planar because we have 3 electron domains which form 120-degree bond angles. Since all the bond angles are equal and all the domains are the same, SO3 is nonpolar. The second molecule we're given is OF2. First thing we have to do again is draw the Lewis structure using the valence electrons, which total to be 20. We place around and get this. Then we know that F is more electronegative than O, since O is the center atom of the molecule, so the bond dipoles are going to point outwards towards the F. Then the molecular geometry of OF2 has 4 electron domains, being the 2 bonds to the F and the 2 lone pairs of electrons. But the molecular geometry is bent because the 2 lone pairs aren't on the molecular geometry. We know that the dipoles don't cancel because since the dipoles are pointing downward and outward, the 2 downward dipoles cancel, but the ones that point outwards do not. Since the domains are not the same, being the lone pairs and the bonds to the F, and the dipoles don't cancel, this molecule is polar. The third molecule we are given is BeCl2. I've already drew the Lewis structure for it using the 16 valence electrons and get where I get this. Then, since we already know B is less electronegative than the Cl, we know the bond dipoles are going to point outwards towards the Cls. The molecular geometry for this and the electron domain geometry for this are the same, being that there are no lone pairs. It is linear with 2 domains and a 180-degree bond angle. Since the bond angle is equal and the 2 domains are the same, BeCl2 is nonpolar. The fourth molecule we're given is CCl4. I've already drew the Lewis structure here with the 32 valence electrons being 4 from C, 28 from the 4 Cls. And we know that C is the least electronegative out of all these since it's already in the middle. So all the bond dipoles are going to point outwards from the C to the Cl. Then the molecular geometry of it is tetrahedral because it has 4 domains among the molecule. Since all the domains are the same, the bond angles are the same since it's all the same. The bond dipoles cancel. CCl4 is nonpolar. The last molecule we're given is O3. So the Lewis structure is right here. We have 18 valence electrons, but we see that the middle oxygen does not form an octet. So we have 2 different resonance structures we can draw, which form into a resonance hybrid right here. So, with that, the electron domain geometry has 3 domains and it's trigonal planar, since they have the 2 bonds to the other oxygens and the lone pair. but the molecular geometry is bent because it has the two bonds but no lone pair. Since the domains are not the same and the bond dipoles don't cancel, O3 is polar. So, out of all this, we've determined that SO3 is nonpolar, OF2 is polar, BeCl2 is nonpolar, CCl4 is nonpolar, and O3 is polar.